Hello everyone, I'm Khosa. I'm back again with a video. Thank you guys to continue subscribing. I'm here brought to you important information. So what means differentiation? How to apply differentiation. So our today's concept is focusing on logarithmic differentiation, exponential, like how to derive. So let's start with the word implicit. So the word implicit, we are given a function y, it's f at x. When we say implicit differentiation, we are deriving both sides. So this, for us to find the y over the x, we did implicity from the start. Just that some of you couldn't see. So this means that we have d over the x of y, which is the same as d over the x of f at x. So this is nothing but dy over the x, which is f prime at x. So this concept is been there from the start. So now let's focus on our formal definition of differentiation. First principle. This is your first principle, as you see. All know first principle from high school. So let's continue. I need you to focus on logarithmic today. Logarithmic functions. So we are going to derive logarithmic functions. So we have the natural logarithmic, we have the log, as you know. So without waste of time, let's look at the laws before we go further. Laws, that's the first thing to look at. So let's look at the first one. The first one we say, our function f at x, it can be written the same as e to the power ln of f at x. Or the same function can be written as ln of e f at x. This is the first logarithmic law. So the second one s. So whenever we're having the log of e f at x, your base is e, it's a natural logarithm. This one is always equivalent to the ln of a function. These two are very much important, especially when we are going to exponential or derive functions of exponential form. We need this law. So number 3, it says the log of base a x. This can be written as the log of a x over the log of a b. So this is nothing but log of x over log b. We can take this further to log e x all over log e b. I'm not saying a and e are equal, but the ratio of log ax over log ab and also log ex and log eb, they are the same. You get a point? So this will end up by this second one. We say whenever a base is e, it changes to ln. Automatically this changes to ln x. You see? Divide by ln b. That's how interesting is mathematics. So, number 4. What about log of bx times y? So, log bx times y, this one can be written as log bx plus log by. Remember, log bx is ln x over ln b. It means also log by is ln y over ln b. So this, it can be written by ln x plus ln y all over ln b. And this ln x plus ln y is nothing but ln of x multiplied by y divided by ln b. Let's come to the one where we're using log bx divided by y. So log bx divided by y is log bx minus, because of the division, log by, which is the same as ln x minus ln y over ln b, which is nothing but ln of x divided by y over ln b. So, you see these important laws, they are important. We are going to apply them, you'll see. So, number 6. What does number 6 is? Okay, yes. I forgot what I'm talking about. So, the ln of a function all to the power n. This must follow n, the ln of that function. So is so is the log of base x to the power n. This must follow n log base x. So you know this one. This last important one, these laws are not all of them, but the ones which I gave you are very much important and applicable. So whenever you are having the 1 over log xb, this will be always the same as log bx. Let me specify this one, which is also kind of like important, but this one, it was being derived from this. Look, we're having the log of what? The log of e and e. So this one is the same as the log of a and a, which is what? So which tells us that whenever we are having the log of any base 1 will always get 0. So this implies that the log of any base 1 over the function is nothing but negative the log base of that function. E.g., an example of this. You remember the reciprocal of sec is cos, right? So, referring to the ln of sec x. So the ln of sec x is nothing but the ln of 1 over cos x, which is directly the same as negative ln cos x. Hopefully you understand. These ones are the 8 important laws that we're going to use. So can we proceed? Just look at them, meditate on them, you'll grab this thing. They are very much simple. So let's proceed. You can be having a function of form f at x can be the same as g at x all to the n. Okay, let's continue. Whenever having a function of this form is to the power y. So you can just introduce the ln both sides. Ln f at x, ln g at x, all to the power, right? So, as you can see, this it will imply that, this, as you can see, is the same as y ln at g at x, which will imply that your y can be written as ln f at x all divided by ln g at x. And for you to find the derivative, it will be much simpler. Let's now focus on exponential and logarithmic differentiation. Now that we know the rules and the laws. So, according to, let's focus on exponential and logarithmic. Differentiation. So, we are given your function y is given by e to f at x. According to this logarithmic, when we substitute this function on exponential, on this first principle, we are going to find that our dy over dx is nothing but f prime at x multiplied by e to the f at x. And also, we know that if y is the same as ln of f at x, we can write dy over dx as f prime at x divided by the function itself. So this is your exponential, this is your logarithmic. So now we need to apply the two on whenever your y is given by a f at x. So we need to apply the logarithmic and exponential. We are going to introduce the ln both sides. Ln y is the same as ln a to the power f at x. According to the rule, f at x will go down, we take ln a. So, we can take this back by your y is the same as e to the power ln y, which is nothing but e to the power ln a f at x. So, with this rule, we are going to derive using exponential, this one to derive this. So, in other words, now your dy over dx is nothing but, we said the derivative of the power function, which is d over dx of e to the ln a f at x multiplied by e to the ln a f at x. So looking at this, it's nothing but the derivative of the power, the derivative of ln a f at x, not e, is given by ln a f prime at x multiplied by y itself. So in other words, the answer is what? The answer is ln of a f prime f x multiplied by a to the f at x. So this is how we are going to derive any function of this form. Thank you for watching. Continue subscribing to my channel. You're all welcome.